everyone, welcome this morning to our October event. I thought it was November for a second. We are joined this morning by Jason, Gabrielle, and Clayton from the team, and we are very excited to bring you an update on Skylark 0.2. So as always, this event is being recorded, and if you have any questions, just put them in the question box on the right-hand side, and we'll get to them at the end. And I will now leave you with Clayton.
Morning, everyone. Thank you for joining. It's bright and early here, but I appreciate everyone's joining from different times around the world. I'm just going to take you through a bit of a background to, I guess, the last time we gave a sort of public talk about Skylark 200 and the project we'd completed in Derbyshire, in the Peaks district in the UK. For those who remember it, we built this garage and sort of small office space up in the Peak district, and we sort of got a group of volunteers together and assembled it over a weekend and a couple of extra days. And this was the first really sort of full-scale public test of Skylark in the wild. And we found that generally a lot of things worked really well. We're really happy with particularly the use of the bow tie connectors, building on a concrete slab for the first time, looking at how we do roofs with Skylark, particularly pitched roofs, gable roofs. But we also found there were a few sort of challenges as well with this approach. That's a finished article for those who haven't seen the sort of finished pictures, which is, the client's done a really good job of finishing that off and, making a really nice building of it. And so we were able to send a photographer back to get some nice images of the final article. So it's now being used, which is good. But as we did it, we learned that there were some things that worked really well. So obviously bow ties, we were able to lift the floors into place. They weren't too heavy. We could manage with the genie lift. The super soft insulation, rolled insulation was great to work with, especially for stuffing into small corners. We found it was generally pretty accurate, even given that we're building on a concrete slab, which has probably got some sort of site tolerances to it. And we did it with volunteers. And where there were things that were either sort of errors with the cutting or bits that we hadn't sort of anticipated, we could easily hack it on site, which is one of the great advantages of plywood. But one of the things that was really frustrating with this for everyone involved was that the system of using these combs to join elements vertically, so connecting the walls to the floor and to the roofs or walls above that, was quite problematic. One, because the insulation was really hard to fit around it. You had to then stuff it in the top, as you can see Mel doing there. And then you also had to use pegs to connect the combs to the wall and floor blocks. And that meant driving the pegs through the insulation or trying to push the insulation out of the way to make space for the pegs, which meant that potentially opening up issues for cold bridges where there's bits of uninsulated wall or floor. And also it was just a bit of a fiddly process. The combs themselves as well, it's a sort of its own system. So it doesn't really match up with the logic of these 600mm blocks. So you had to get your mind around another whole thing about, okay, which comb goes first, and what order do you put them into? You had to sort of line them up, and then particularly for the end blocks and for the verges, then trying to position those blocks on top of the combs meant that you had to line everything up perfectly. And if there was things, some warping or things were slightly out in terms of tolerances, it was a really sort of wrestle and struggle. So we wanted to find a way to make this whole connection much, much simpler. Ideally eliminate combs entirely because it's a lot of extra material. The main purpose was, yes, they could help as lintels, but the main purpose was really that they was to hold everything together vertically to prevent sort of strong winds uplift of the roof pulling away from the walls and the floor lifting up or anything like that. So it's really to hold everything down and create this sort of chain reaction down to the foundations. So we took that forward and we said, okay, well, we presented this problem. What if we could just get rid of these and find a much easier way of doing this hold down connection? So I'll pass over to Gabri from our team, and he can take you through some of the concepts and investigations that we did, looking at potential options, ways we can make this simpler, and then we were able to take this through and do some testing in the lab. Gabri, are you there?
Gabri, sorry, can you please unmute yourself?
Thanks, Mel.
Thank you.
I appreciate it. Just said, yeah, good morning, everyone. Also from my side. Thanks, Clayton, for the nice introduction and taking us through the lesson learned from PickBards. So the question is, if can we get rid of comms entirely? And so we as a team came up with sort of two different options. The goal is how can we connect walls and beams so there is less uplifting force, and we came up with two alternative connections. You see the option A on the left is sort of probably something that looks like a timber dowel connection. So it looks like a peg, but it's much shorter. Is 38 millimeters. So just to go through the external sheet of plywood, and we have a similar connection on the internal face. And then we have option B, which is using some bow ties. Now the bow ties you see on option B are slightly different on the bow ties that you probably were familiar with in version 0.1. Specifically, we got rid of the middle hole because it didn't have much of a structural capacity. And also you see sort of double ears, sort of like Mickey Mouse shape. You will see through this slide that actually the bow tie evolved during the process. But the reasoning behind that was we were concerned a little bit when pulling the two members apart if the bow ties could fall out of plane. So we thought, oh, if we have 4 anchor points and we can put a little nail in any of them, then there's not going to be a risk of that. Now, we didn't notice anything like that in the test, so you will see we reverse back to a single ear in the final optimization of the bow tie. So as Clayton was saying, we approach the problem from a constructability point of view. Can we make a connection which is easier to install? But also we took the chance to ask ourselves, oh, that connection, what if we can make also something that is stronger and stiffer? So those were the two options we came up with, and we team up with our partners at University of Strathclyde, and they gave us the opportunity to do some testing in the lab. And you see there are some of the sketches and actually the testing, the specimen that we brought into the lab. Just to give you an overview of what we did. So if you immediately lift up the green wall, so you have some wind loading, which is uplifting your wall, the force has to travel into those green tabs before it reaches the blue element. So it travels into the side green tabs and the frontal green tabs. Then it reaches the timber dowels, the red elements, and then it can be transferred into the blue beam, which is connected to the foundation. So the force has to travel 2 different interfaces, and that's what we basically tested. We had already information on the green tabs on the side, so we already had some experimental results of that. So we decided to test the interface in the front, and then we tested the timber dowels on their own. So if we came up with the machine you see is called universal testing machine. It's basically pulling the 2 panels apart, so we could have information about that. And you see some black dots. I will show you later some of the results. It basically to track the stress and strain deformation locally around the joint. For what concerns concept B, you see the flow of the force is much straightforward. So the force from the green element just travels into the bow tie and directly into the beam. So already at concept level, seems that concept B is already a little bit more a straightforward option. The force doesn't go too much around, is kind of straight path, which is at the end of the day the connection that we end up choosing for a number of reasons. And we tested the single bow tie, so we want to have a sort of a benchmark what the capacity of one bow tie is. And then we also tested 3 bow ties together. Now, the reason we did 1 and 3 was because when you work in timber engineering, especially when you work with connectors, sometimes you have a group effect. So 3 is not equal at 1 times 3. When you work especially with nails or screws, you need to reduce the capacity of the wall group when you have more than 1. Luckily, this one was not the case. So actually, we could verify that the capacity of 3 bow ties is actually the capacity of 1, which was very good. And that means probably that bow ties are equally spaced, as they don't affect too much each other. So I wanted to show you a video, but it didn't work out too well. So this is a screenshot, but you can find it on YouTube, which basically shows you the failure mode of the bow tie. So the way we observed the bow tie failing was that we were expecting the bow ties to break in the middle, which was the weakest point, but that didn't happen. Actually, what happened is that the bow tie kind of slipped through, so it kind of came out of the connection, and the capacity was still pretty good, but that gave us some food thoughts for us, thinking, oh, we can even further optimize the bow tie and the shape that we tested in the lab. So results were encouraging, but we took that, we applied some classic models of timber engineering when you start looking at different failure modes, and you see the picture on the bottom right. So at concept level, your bow tie can fail in the middle for tension. It can fail on the side if you have too much compression going perpendicular to the bow tie. It can sort of deform in that weird kind of wing with lateral wing sway when you have a surface force, or you can break in shear. So we sort of, for any of this failure load, you can calculate a number, and if what ideally would you like is that these numbers are close to each other. So if you can optimize the shape of the bow tie, you don't have a failure mode which is dramatically governing the design, and that makes you basically using the material as much as possible. So we took the experimental results, did some modeling, and at the end of the day, we came up with the geometrical properties that you see on the left. So the bow ties is actually probably smaller. You will see when we're going to put it in perspective with the wall than the one we had before, and is also stronger, which was very good for us. So why we think this is important from a structural perspective? If you remember when we tested the walls in the lab, what is governing the capacity of the walls is not the wall block itself, but is the hold down connection. So the way we tied up the wall to the beam. So that connection that before we were doing with pegs and combs, now we're going to do it with bow ties, and that's critical pretty much for the performance of the system. And we were able to almost double the capacity by this new connection, which is very good. In terms of stiffness, the increase of stiffness is going to be at least 25%. Now I need to say at least because it is 25% when we benchmark the connection with each other. So the 3 bow ties versus the pegs is 25% increase of stiffness, but it's probably going to be a little bit more than that because the load path is actually straighter in this case. So I personally feel it's going to be a little bit more, and we don't have numbers to prove that, but if at some point we're going to carry out a larger scale testing on the walls, that would be my expectation. Now, there's another side benefit, which is because the bow ties are smaller, it's not a matter of having better connectors, but also we can place more of them. So you see, for example, on the if we slice up the wall vertically, in the past we could only place, for example, 4 bow ties to take the differential shear forces along the wall. But in this case, we can place double. So that means again that our wall is going to be overall stiffer because we have more connectors, is more tied up together. So it's going to tend to work more as a single continuous wall rather than an assemble of elements. So that's very encouraging, and hopefully we can at some point do another larger scale testing and see how much we we gain out of that. So I think that's pretty much all on my side, and I will pass it on to Jason.
Hi, everyone. Thank you, Gabri. Yeah, so we're very fortunate to be able to test these new connectors in a real project. And many thanks to WikiPavilion for contacting us to create a WikiPavilion in Milton Keynes in the UK. So it's a pop-up exhibition pavilion commissioned by the City Council, forming the backdrop of the Archive Opia events, and to showcase Milton Keynes' local heritage and also various archive collections. So working with Simon from WikiPavilion and Alison from Urban Fabric Architects, we spent around 2 months coming up with various design options. So we experimented with different roof forms, different wall heights, and eventually we settled on a salt box roof to evoke a playhouse and also to reference one of the historic houses in Milton Keynes. So the internal dimensions are 4.8 by 1.8 meters, and it has a 3 meters wide front double door opening to facilitate it being used as a stage, and also a single door opening at the rear face for ramped access. So this, they wanted to showcase the aesthetic quality of the chassis and also the construction methods by keeping it bare. And yeah, no insulation was needed in this case. Besides that, the pavilion was designed to be dismountable, meaning that it could be relocated to different venues in Milton Keynes. So we thought using these new connectors made it easier to achieve that. So like our first Peaks-bound project, we had Letitia from Momentum Engineers, who did a great job in staggering the structural checks to help us speed up the manufacturing process. We also worked with Piyush from Hulk Build, who also did a brilliant job and have been very supportive throughout the journey in testing out the new bow tie connections, pre-screwing the some of the joints as per Letitia's feedback, and also getting the blocks ready for pre-assembly. So before actually going on site, WikiPavilion assembled a team to test, build, and dismount the pavilion for fire coating using the site assembly manual that we've provided. So the build took around 8 hours and also 4 hours to disassemble. So yeah, it went smoothly with a few hiccups, which we would later encounter on site. But yeah, they were all quickly solved by the amazing assembly team. So here's our first site, which was a basketball court at Kent's Hill. It was a Sunday morning, and the lorry with the blocks was parked nearby. We had about 9 people on site, and we carried the blocks up to the court and stacked them around the periphery of the court. So the pavilion would be situated in the middle of the basketball court. So first thing, we laid down the timber sole plates, and then we hooked the floor blocks onto it. Since the ground wasn't very level, so we had to strap the floor blocks together so that we could fit the bow ties in easily. So if you can see the bottom right image, it's basically one of the new bow ties that we've developed to connect the floor blocks to the end blocks together. Moving on, once the floor blocks were completed, we proceeded with installing the wall blocks on the sides. So we have also tested developing some sort of wedge tool to connect the bow ties between the internal face of the wall blocks to the floor blocks. So it's still not fully developed yet, so suggestions are welcome. So once the side wall blocks are were completed, we moved on to the gable wall blocks before we installed the openings. So if you can see from the far right image, there's a vertical hole on the side of the wall block. So this was where we would insert the lintel of the door piece and hook it into that wall. It was a bit of a challenge. So the original idea was to install the door blocks, followed by the adjacent wall block and then the corner block. But that didn't work because we didn't have enough space to rotate the wall block at the bottom. But that's okay. So the solution was we removed some of the bow ties at the door block. So we had a team where we would lift up the door block, hook the wall block into the door lintel, secure the wall block, and then drop the door block. And whereas the front double door opening was a bit more straightforward. So we found out that we had to insert the side parts of the far left and far right of the gable wall blocks, as you could see from the bottom row images, the first one and the second, so that we could easily then insert the remaining gable wall blocks from the top onto the lintel. So to complete the gable wall blocks, we covered the bottom with the horizontal pieces. So as you can see, the sky was getting a bit gray, so we decided to call it a day. What's remaining was the roof blocks, and essentially the assembly team created this temporary tie, as you could see from the top right image, between the wall blocks. And also we placed all the roof blocks and equipment into the WikiPavilion and then covered it in tarp. So day 2 came, and so we had around 6 people on site, and we first installed the ridge beam, which it was made up of 2 times 18 ply sheets spanning across the gable walls. And the assembly team also created this T-brace tool and also a temporary tie to help to guide the roof blocks up and also to click it in nicely with the ridge beam. So once that's secured, we immediately secured the ends with the bow ties. So one of the things that happened was, because this was the second assembly, some of the blocks became a bit wonky and a bit out of shape. So before we could insert the final last roof block, the ridge beam actually came off. So we had to quickly install some temporary support and also use a sash clamp, and we also made some sort of timber tie to bring the walls in, and eventually we managed to fit everything nicely. It was a really good hack. Yeah. And the last remaining bit was actually install the steep roof blocks. Which was also it's actually more straightforward, but only we had to jiggle the last bit a little bit in place. And then the team used the sash clamp to line some of the sections together, and then use the bow ties to hook them into place. Yeah, so towards the end of the day, while we were completing the chassis, the door manufacturers came and installed the doors and also the ramp. And Alison, the architect, started preparing the exhibit for the following day's opening. So here's a quick time lapse of the build over the 2 days. So it has been a lot of fun. We had a lot of fun, and it has been a great learning experience for all of us. So the pavilion stayed outdoors on this site for 2 nights, and fortunately it didn't rain. And then it was disassembled and moved to the next location. So from there onwards, it will be indoors. And it's the Milton shopping mall. Yeah. So Piyush.
Beauty. It's just a thing.
So Piyush went to. So Piyush went there to visit, and here's a video that he made. And yeah, it's looking great with all the graphics. So now it has been moved to the final location, which is the Milton Keynes Central Library. So if you're around the area, please come and visit the pavilion.
Thanks, Jason. That's looking great.
Yeah.
I'm gonna hand over to Clayton just now.
Yeah.
Hi. Thanks, Jason. So I'll just take you through, for those who have been looking at the WikiPavilion project and the engineering work we've done and said, how do I get my hands on these files? 0.2 looks great. Looks like it's working perfectly. I want to get started. I do have to say, just hold off a little bit in a minute. We are working on these files and trying to develop some of the other key junctions in there. There's a whole range of blocks we need to develop. But if you are sort of chomping at the bit to get going, there is a 0.2 version sort of alpha release or work in progress release that we've put up on GitHub. There's a link to this in the new community forum, but I can also send it out, post here as well. So what we want to do is expose our sort of work in progress designs as we're going, because I think there's a lot of people out there who are sort of actively testing and building things or manufacturing things, or just want to keep an eye on, I guess, the direction of travel where this is going. And because this is quite a new revision, it does, like I said, remove combs entirely. So it means that the changes affect all the blocks, right? So it's going to, particularly the junctions between floors and walls, which now just use bow ties. We've also taken the opportunity, as Gabrielle mentioned, to add extra bow ties and really strengthen up those connections. So overall, it's a massive improvement. But there is still work to be done, and I will caveat that some of the things we need to work on are lintels, as Jason mentioned. You won't find any blocks for those yet in the design kit. That's something we need to experiment a bit more with first. And also there's some other sort of assembly challenges around how do you deal with these gaps down the side, the gable end walls, for insulating those gaps. And also we're hopefully developing more roof forms and also a system for internal cross walls where structural cross walls are required. So all of this is going to take some time, but in the meantime, the way this works is that in the GitHub, which is the library that's connected to the WikiHouse block library, is that we started with, so the first release was 0.1.1. We have done version 0.1.2 release for the Skylark 200 system. But now there is this other branch on GitHub, which is going to be our development branch, which we'll use to test and trial and sort of pre-release early versions of the next systems that are coming up. And the current one we're working on is, we call it 0.2 because it is quite a holistic change to the way the system works. So if you want to delve into that, there are models available in a few different formats. Not everything at the minute because of the way that the CAD files are structured. So we've got in DWG and SketchUp and Rhino. If there's really a request for a lot of different file types, we can try and do some exports, but they won't work as well because all the models are broken down into sort of subcomponents. So trying to keep that, I guess, easy to use, and also easy if people do have suggestions and feedback. And that's one of the things that we're really keen to see is if you really like to tinker with these kind of things and you can see some obvious issues, then do send some feedback and post some suggestions or ideas. So ways you could help us improve it, or prototype some. If you've got access to a workshop, it would be great to see these being tested at full scale or small scale. Design and build pilot projects, you're welcome to take these and use them. I mean, they are very much as is, and so heavy caveat that they are work in progress, but if you wanted to do some small projects with them and work with engineers if you need to, that would be great. And in the process of that, anything you can suggest in terms of improvements to the connections are definitely useful. Ways to make it simpler, ways to particularly speed up the CNC machining, that's always of interest. It's not a massive blocker to this system, but we want to find ways to be more efficient. And of course, suggestions for new blocks, or start developing your own custom ones would be great. And yeah, if you have a project in mind that might be interested in using this new system, get in touch and speak to us, and we can potentially help you with some of the design work. So where does this take us next? So by next spring, we've got a sort of roadmap of things we want to be launching and working on. First, of course, the version 0.2 alpha branch. That's both across Skylark 200 and Skylark 250, although currently the models are only for Skylark 200. We will be working on Skylark 250 ones very shortly. And once that's got to a sort of point where we're fairly happy with it and the connections all work and there's logic that follows through all the blocks, then we'll be updating the library on the WikiHouse website as well, and updating the main GitHub branch. And then in the process of that, we will hopefully be building a few more pilots and testing blocks in situ, and hopefully there'll be others around the world who will be doing the same. On the community side, we're going to continue with this monthly web series. We'll hopefully hear from more WikiHouse contributors and people building projects. And as you might have seen, we've also set up the community forum, which you can link directly through via the website. You don't have to log in anymore. Unlike Slack, you can just keep an eye on what's happening. And generally, we're going to be moving away from Slack as a resource. We'll keep it there for the next little while as a way for people to chat and connect and stuff like that. Quite good for that. But for the resources and info and what's happening and latest news, definitely go to the community forum. And then one of the big things that is on our agenda is working through a certification process, at least within the UK initially, for how we can provide some competent assurances to mortgage lenders and insurance companies and everything like that for built projects where they require those kind of things. So we're going to be going through a gap analysis process, which will probably involve, after that, they'll come back to us with a list of requirements. Some of it may involve some further lab testing and research, potentially around fire. And then we can work through with the manufacturers that are in our network as well to develop a really standardized way of manufacturing these. And all this documentation that we're developing for this will not just be for certification for us, but we'll put it up on our website and in the guides and make it available for others who might be facing sort of similar challenges with regulators and insurers in their part of the world. And then the sort of secret project in the background at the minute is being in a position to launch an initial sort of digital configurator for doing some basic design work. Initially targeted at Skylark 200 and small single-story garden studio type structures, but for those who want to get a quick indication of pricing and what they can build with it, we're launching a 3D customizer again by next spring that will replace the need for using CAD to be able to work out the quantities of blocks in your design, put an order form through, work out what sort of quantities of cladding and insulation and things like that you might need as well, and get some sort of indicative pricing of what it might cost. And then I guess the last message on that as well is if you are already building with Skylark 0.1, don't freak out. Skylark 0.2 is, yes, it's a full upgrade, but all the dimensions of all the blocks are the same. So it will be a case of, and all the naming systems are very similar. So you'll be able to swap blocks in and out if your project ends up being later on. But so do continue working with those models. It's not going to it's not going to have a massive effect. And also Skylark 0.1, as we know, works really well. There are a few little challenges, but there are also things that we don't know yet about Skylark 0.2. So if you've got something in production, definitely stick with what you have. It works perfectly well. We've done several projects with it now, and like the peak barns, and we're really happy with it. This is just a way to, I guess, continue the development of the system. Cool. So I will hand over to Mel and the rest of you, and if you have any questions, there's seems to be a few posted already. We can happy to answer those.
Yeah, let's start with some questions. So we have got something from Vincent about the WikiPavilion. So who would like to answer that? How do you disassemble the bow ties, especially when there is some tension on them?
Yeah, I can answer that. Let me just bring back the previous slide when we're doing the sample. Sorry. There you go. So it was actually quite straightforward. So essentially what we did was we screwed in two screws on the ends, and then using a crowbar, and also on one hand we have the other bow tie to actually block out the roof, and we just pull it. And then for the other side of the bow ties, we just use the back of the crowbar and just poke it out. So we prepared extra bow ties in case if any of them got broken. Yeah, so there wasn't much tension on that.
And did you have lots of spare bow ties, Jason? Do you have to bring loads and loads?
So in total, we for the pavilion, we needed like around 600 bow ties, 650 bow ties. And WikiHouse manufactured like an extra 100 or so, just in case. But yeah.
Great. We've got another question. Can you tell us a bit more about the configurator, or is it top secret?
It's not very top secret. I'm sure you can find it if you need to. It started as part of a project that we were working with as part of an EU-funded Interregs project with a number of different providers. But we are now keen to build a WikiHouse instance of it. We already had some test projects running from the WikiHouse Swift system in Almere in terms of their house types. It'll be, there is an online version which we can do a post about in the community forum. I think it's probably the best thing to do a bit of an explainer. It is, again, very early stages, and it's we know it's far from perfect, but I think by focusing in it on doing some simple WikiHouse designs with it and launching those, and working all the way through the system, not just about it being a customizer, but being able to then take you to where you need to go in terms of manufacturing and getting design help and things like that is going to be really useful. And as well as giving you actual fairly accurate quantities about materials in your building. So yeah, well, we'll do a little post in the community forum. I think it's probably the best place to put that, and we'll put a link to a very early stage version, which doesn't have any Skylark stuff in it yet. That's still in the works, but at least you can have a sort of sense of what's going on.
Great, thanks. I think this one's for Gabrielle. Is there any more testing planned?
Yeah. So as Clayton was mentioning, we are going through a sort of a certification route with some gap analysis. So at the moment, there's nothing planned specifically on the structural side. There's something planned on the fire side. So we are trying to come up with way of thinking how to protect a WikiHouse from fire, and that basically depends on the number of stories and how close your building is to other properties. There are different ways of doing, for example, how to install some gypsum board on the inside. So we're kind of working through some concept design on how the fire detailing might look like, and we're trying to find a way to do some preliminary testing, regardless of actually of the certification, in order to have an idea how a WikiHouse performs on fire and how gypsum board can stick, for example, to a Skylark wall or a Skylark bin. So not too much on the structural side yet, but we are putting a lot of focus on fire at the moment. Yeah, so hopefully we can do some testing soon.
Great. Clayton, I think this is for you. What does it mean once you get certification? What does it mean for the product?
Well, initially it means for the UK product that it'll make it easier to get some mainstream mortgages and building insurance. Now that only really affects houses mostly and larger commercial projects. For those doing garden studios and anything sort of underneath building regs, it's not really going to be an issue. It should also make it easy to go through the building regs process. But this is just one step along the way. There's a myriad of different certifications, and we're just starting with one. You can get all sorts of overlapping ones, but we think this is a good first step, and it'll mean for anyone who's building with WikiHouse through the sort of official routes that it will that you're much more likely to be able to go to a high street mortgage provider and get a mortgage on a property. So that makes it much more, I guess, adoptable and usable, and less sort of fringe as a system. After that, we could look at if we have a sort of manufacturing network growing within Europe, extending that to CE marking for European certification. But that is much further down the line. And honestly, this process doesn't happen quickly. We're anticipating that it won't be until probably this time next year that we potentially will be certified to that level, but it doesn't stop you from building projects, and there are other routes to get mortgages and get building insurance and go through building regulations without having this in place. This just makes it much easier.
Great, thanks. We've got another question from Danilo. Would you be able to say how much the cost of the WikiPavilion was? Does anyone know the answer to that?
So all in all, we needed around 90 sheets of ply. And then I think at that time, the cost of ply sheet is around £40 per sheet. So in total, it's around 3.6K just for the material.
Great. Another question is, are you making changes as a result of what you've learned through the WikiPavilion?
Yes, most of them are tweaks rather than massive changes, I'd say, Jason. But there's a list of things that you found out, particularly how we deal with lintels is a bit of a question mark still. But there are small improvements we can make, including things like tolerances in some places, small sort of chamfers and fillets on some of the slots. Basically things that make the assembly a bit more straightforward. Those are the main ones. Anything else I missed?
No, I think
you mentioned the wedge tool. You still were trying to improve that. What's that about?
Yeah, basically because now that we have like bow ties on the internal faces of the wall blocks to connect to the floor blocks to make it more rigid. So we just need to develop maybe a better sort of wedge tool in sort of securing the bow tie through that gap. So because when we hammered in the wedge tool, it actually fits the bow tie in, but then it was quite difficult to remove the wedge tool after it's hammered. So Piyush was suggesting that we can use some sort of like T-shaped wedge tool to basically, and then we just need to knock the back in and smack in the bow tie in place.
Brilliant. If anybody has got any ideas on how we can improve the wedge tool, please let us know. I don't see any more questions just now. So I just wanted to say, as Clayton said before, please join the community. We've had some posts from people all over the world now, especially if you're not in the UK. We'd love to hear from you where you are. We always get emails from people wanting to connect with each other, but it's much more efficient if it's in a place like Discourse, so you can actually find each other wherever you are in the world. Finally, I was just going to say, Clayton, so the request for those wanting to explore the development branch is, can you remind us what we would love help with?
Well, the first thing, I think if you've got access to CNCs or laser cutter, just building some small prototypes would really be great. It's the best way to get your sort of hands on it and understand how everything works. But specifically with the blocks that are there already, and we'll be adding more as we go in the coming weeks. So we're trying to keep it sort of fairly live and up to date with where our sort of thinking is. There is some work on other blocks that we haven't added into there. So there's only one roof type in that one, which is a sort of slightly, pretty much flat, 1 degree pitch roof for mostly the small studios. But we'll be adding a gable roof type as well, and possibly an angled roof, a slope roof. Yeah, anyone who wants to sort of delve into having a go at those blocks, that'd be really cool to see, because building on the same sort of logic, and you'll see that logic quite easily in the when you open the models. There is there's a bit of sort of work on lintels, I think, and we don't have any blocks in there yet, but we'll add some, and then you can start to work through that process. But just building up whatever you want to create, your designs, using these sort of work in progress blocks, will hopefully sort of find out any issues if this clashes, bits of stray geometry, any sort of issues like that. We're keen to pick up on. Hopefully, it won't be too much of that. But yeah, as you're building your models, if you find there's parts that you need that don't exist yet, definitely request those as well.
Brilliant, thanks. And yeah, if you have any questions or want to start a discussion about the development branch, you can always go on to community.wikihouse.cc and start a thread there. We'd love to join that conversation. I think that's us from today. Oh, no, we've got one more question. I'll put it there. Are you guys turning 3D models manually into CNC ready 2D CAD files, or have you developed an automated way of doing this? Would anybody like to answer that final question?
It's a half-half. I mean, there isn't a magic solution to this. There are some cool web tools, and maybe at some point we would really make use of those. At the moment, we're using Rhino internally for most of the modeling work, and we normally manually nest those parts onto the outline of a 8 foot by 4 foot sheet, And the reason why we do that manually is because it changes often, but not too often. And if you had even if you're using nesting software, it's still not as good as sort of the human eye. And we want to. It's actually a really useful R&D process, because you start to work out where joints should be in elements, so that the parts fit really neatly onto a sheet and use the least waste possible. So it's a to and fro thing, and I think the best way to do that is actually to do that manually. But the benefit of having these standardized blocks for Skylark is that once they're sort of nested, if you make changes to the geometry, you don't really have to re-nest them very often. It's only if parts end up getting longer for some reason or smaller, which doesn't happen too often. So the other big thing that we do is, because we've got so many blocks and so many sets of sort of laid out 3D parts then on sheets, and we do have a little Grasshopper script that just turns those into basically single lines for cutting that we can export into DXFs. So it adds some tolerances to it, and it lays it out. Sorry, it doesn't lay it out. It just creates the right layers and lines for CNC milling. But to be honest, you don't. What we're trying to do is that we'll only need to do that once. Once it's online in the library, then the cutting files are there for you to use anyway. And you won't have to re-nest them. You won't have to reproduce the cutting files, because you just say, okay, I want 10 wall blocks. Here's the cutting files for a wall block. Cut this one 10 times. So it's only if you're really tweaking the engineering of it and looking at developing your own custom blocks, and you've got lots of bespoke elements, that you'd have to do your own nesting process for this. And we're happy to make some of those scripts public if that's really going to be useful for people. Otherwise, there are other ways. You don't have to use Rhino, of course, and there are other nesting softwares out there. Some of them, there's a few that are open source that are all right through the web. And in terms of doing the layers and stuff like that, you can do that with CAD. Yeah, if the project is small enough, it's almost quicker to do that manually by hand than running a script. That's just sort of the way things work. Yeah, that's a good question.
Thank you, Clayton. I think that's us. Thank you so much for coming. If you have any more questions, you can always add them at the bottom of the video. The recording will be live in a couple of minutes, I reckon. Join the community, as I said, and we'll see you next month, because we have an event every month. So I'll put details of the November event up soon. Thank you very much, and we'll see you soon. Bye.